In this video, we're going to look at a family of useful R functions called the apply functions. Apply functions are useful when we want to perform some action repeatedly on multiple data structures at once. Often, apply functions can achieve something similar to the for loop, but in a much faster and more efficient way. So that a simple apply function can often condense a for loop to a single line of code. There are various different apply functions: apply, lapply, sapply, vapply, tapply, and mapply, which are designed to operate on different types of data. So let's take a look at these different apply functions. The basic apply function is designed to operate on a matrix. We use apply if we want to apply a particular function to all rows or to all columns of a given matrix. So let's demonstrate how this works with an example matrix. Let's create a toy matrix called M, which we randomly populate with numbers between 1 and 100. Let's give it 10 rows and 3 columns. Okay, so the apply function will take 3 arguments. First, it will take the matrix on which we want to operate. Second, what we call a margin, which will specify whether we want to apply the function across rows or across columns. So for rows, we would write 1, for columns, we would write 2. And then the third argument is the function name, so the function that we want to apply to this matrix. Let's test this out with simply the mean function. So let's say we want to apply the mean function to find the average of each row in this matrix we've created. Here we would write apply m1 mean. If we were to write instead m2 mean, this would calculate the average of each column. Of course, we can replace this mean with any other function, including any function that you define yourself. Let's say we don't have a matrix, but instead are working with data in a list. So for this, we can use a similar function called lapply. The lapply function doesn't take a margin like apply, but instead it takes just 2 arguments, the first being the name of the list, and the second, the function which will be applied to all of the elements in that list. So let's create a simple example of a list to demonstrate how this works. Let's, for example, create a list called L, which has 3 elements, A, B, and C. The first consisting of 5 integers sampled from 1 to 5, the second containing 10 integers sampled from 1 to 10, and then C containing 50 integers sampled from 1 to 50. Okay, so we have our sample list. Now let's use lapply to find the length of each element of the list. So here we would write, using the same approach as above, pretty much we would write lapply L length. So here we see the length of the list. We could also use a similar approach to find the mean of each element. So lapply L mean. And we can see that the result itself is also in the form of a list. We're reporting the results of the function to each element in our list L. And notice that this is much more efficient than, for example, using a for loop to find the mean of each element, where we would have to say something like, for each element in the list, compute this, and then return this, and so on. sapply is a very similar function to lapply. It can also be used to apply a function to a list, but the way that it returns the result is slightly different to lapply. So this S in sapply stands for simplify. And what this means is that it will return a simplified output, which is, instead of being in the form of a list, will be in the form of a vector. So let's see how this works. So if we run sapply, similar to how we did before, sapply L mean, we will get the same result, but in the form of a vector instead of a list. Then we have vapply. So vapply is also quite similar to sapply, except it requires that you additionally specify the type of data that you're expecting to return. So vapply takes 3 arguments: the name of the list, the name of the function that we want to apply, and then a third argument, which is the type of data that we expect the function to return. So what we mean is that, for example, if we were expecting each item to return a single number, as in these previous examples, then we would specify the third argument as numeric 1, because we expect that when we run this function, we will get one numeric value output for each element in the list. If we were to write numeric 2, this would actually specify that we expect two numeric values as output for each element in the list, and so in this case, where we expect 1, we would get an error, because this is not true. So this is quite a useful function if we want to check whether we're sure the result is kind of what we expect. Let's, for example, use a function that will return two numeric values, like the range function, which will take a vector and then return the range, so both the minimum and maximum values of that vector. And so if we use vapply to apply the range function to our list L, we need to specify numeric 2, because we expect two numeric values as output for each element. So if we run this works. But if in this example we were to write numeric 1, we would get an error. Next, let's take a look at the tapply function. Tapply can be used if we want to apply a function on some data which is separated by a certain factor. So tapply takes one additional argument, which is called an index, which basically indicates the factor on which the data should be separated. To demonstrate this, let's use one of the example datasets that's built into R, the iris dataset, which reports sepal length and petal length and width for 3 different species of iris flowers. So let's just take a look at what the data looks like. We have these 4 numeric columns and then this one factor, which contains 3 different kinds of flower. So we can use tapply, for example, if we want to find the average of one of these numeric columns, but separated by species rather than overall. To do this, we would give the first argument as the column that we want to apply the function to, which will ultimately be a vector, and then the second argument will be the column containing the factor that we want to separate by, in this case, the species. And then the third argument will again be the function name, so in this case, let's just stick with the mean. So here we can see that this outputs the mean of sepal length for each of the flower species. Finally, let's take a look at the mapply function. mapply is a little bit more complex. We use mapply if we want to apply a function to multiple lists or multiple vectors all at once. Here, the first argument is the function that we want to apply, and the subsequent arguments are a series of lists or vectors that we want to apply it to. With mapply, we can also specify additional arguments. For example, we can use the simplify argument if we want to specify whether or not we want to reduce the result to a vector, so similar to what we saw in sapply. mapply has some other arguments which you can look into yourself, which we won't go into in detail in this video. mapply can be a bit trickier to conceptualize, so let's take a look at a few simple examples. To do this, let's again use the iris dataset. And let's say we want to find the mean of the sepal length and the petal length for each individual flower. So we can do this using mapply. And we can basically specify mean as the first argument, and then each column or vector in the iris dataset will be the subsequent arguments. And this will return a vector, which is the mean of sepal length and petal length. This is a very simple example of using mapply, but note that it can be used in much more powerful ways once our questions become a bit more complex. Okay, so there you have it, an overview of the apply functions in R. I hope this tutorial has given you all you need to start using the apply functions in your own work, and I'll also leave some links down below to some useful resources if you want to explore the apply functions in more detail. Thank you for watching.